Hello, we are from Team 5. We are going to present on our selected product, which is mini absorption refrigerator.
So, from our market survey, we found out that in Malaysia, manufacturing is the top economic sector in Malaysia, where Industrial Production Index in 2021, it stated that manufacturing is the top industry in Malaysia, which has increase of production 12.7% since 2013 till 2021. And under the manufacturing sector, is in the electronic and electrical industry is the top industry, with 37.78% of the total exports in 2009 were under electronic and electrical industry. And under the electrical industry, home appliances is the most high demand electrical appliances, which is due to the lockdown where people are required to stay at home. We consider three products to be chosen as our design products, which is first coffee maker, and second induction cooker, and lastly refrigerator. Among these three, we choose to design refrigerator. Why? Because first, refrigerator is an essential compared to the other two. Second, the SGR and market size of the refrigerator is the highest among the other options. And last, the refrigerator need a sustainable development, as the current conventional refrigerator has sustainable issue with it. And these are the product function of refrigerator from our literature. And basically, a refrigerator needs to have sustainable development in terms of its performance, safety, its economic, and also the environment. In terms of safety, the refrigerator must follow the safety standards in 4 areas, which is first, the safety of the refrigerant use, second, the system safety, third, the safety risk by the refrigerator, and lastly, the operating charge of the refrigerant. In terms of environmental, in designing the refrigerator, we must consider the global warming potential, GWP, and also the total equivalent warming impact, TLW. And also, we must know the water utilization in designing the refrigerator. And this is our innovation map, in which our group will design an absorption chiller instead of the compression refrigerator. In our absorption chiller, we will use absorber instead of the compressor, and also we will use free chlorine atom refrigerant instead of the chlorine atom refrigerant in the conventional one, which will cause ozone depletion. And our absorption chiller will be more noiseless, less energy consumption, and also more environmental friendly.
Hi, my name is Nur Ain. I will proceed on the product design for task 2. This mini absorption refrigerator is designed to maintain a refrigerated compartment temperature of 4 degrees Celsius under an outside ambient temperature of 25 degrees Celsius using a new refrigerant that can replace dichlorodiphoromethane furan 12 in order to make it sustainable. The refrigerator performance will be evaluated based on the calculated coefficient of performance. The key ingredients to work on this chemical device project is by developing a new refrigerant that enables them to undergo absorption principles and at the same time able to replace the conventional HCFC refrigerant such as furan 12. It is encouraged to avoid chlorine atom in developing the new refrigerant to reduce the ozone depletion potential in environment. Also, unlike traditional compression refrigerators, this absorption refrigerator does not require a compressor and instead relies on the absorption principle to power the chilling mechanism. Both have the similar cooling effect where it occurs through evaporation process of the refrigerant, but this refrigerator will not involve mechanical compressor to transfer the refrigerant from lower to higher pressure. Instead, it utilizing absorption and desorption process by absorber and generator together with pump that require lower power input, thus it saves energy. The psychochemical phenomena involved is the heat transfer, where we only focus on the heat rejected by the refrigerant at condenser and heat absorbed from the refrigerator space at evaporator. A good refrigerant needs to have high heat of vaporization, higher vapor pressure than atmospheric air, lower boiling point and melting point, smaller molecular weight, lower viscosity, very soluble with water, and if possible, zero ODP. We set the target properties based on the non-furan 12 refrigerant, and we found that propylene is the best candidate to replace both furan 12 and common ammonia water absorption refrigerant. To design a refrigerator, mathematical model for heat transfer can be used based on the new refrigerant thermodynamic properties. For each point, the specific enthalpy may be obtained from the thermodynamic table of propylene. After that, heat transfer is in condenser and evaporator may be calculated by using equation Q m delta H. Then the performance of the refrigerator can be calculated by using COP equation, and the value obtained is 4.73. As it is more than 1, this refrigerator is feasible to be designed. Therefore, the area required for calculated heat transfer can be obtained through this equation. The area for evaporator and condenser are 0.0813 meter square and 0.0866 meter square respectively. That's all from me. Thank you.
Hi guys, my name is Afradiana and I'm going to present the task 3, which is the product design of our absorption refrigerator system. So from the 3D modeling, we can construct the stratigraphic projection of our absorption refrigerator. So in this drawing, we provide the dimension for each of the components, such as the dimension of the cabinet, the height and length of absorber, the size of the generator, and the length of evaporator and condenser. Next, we have the section drawing of our absorption refrigerator. In this drawing, we provided the cross-sectional view from the front view of the orthogonal projection. This drawing provides a clear vision of what's happening inside the absorption refrigerator. Moving on to design selection, where we will be focusing on the material. So first, we are going to look at the material for the condenser, absorber, evaporator, and generator. So for this part, it is important to find a material that have a high thermal conductivity, and it also need to be malleable enough in order to shape the material into any desired form. So there are a few materials that have been put into consideration, such as stainless steel, carbon steel, aluminum, and copper. So the table below shows the comparison for each of the material in terms of thermal conductivity. And from the thermal conductivity, copper gives the highest value, which shows that copper is the best heat conductor compared to other material. So this is why copper is selected for the material for the absorption refrigerator. So next, we are going to look at the material for the refrigerator cabinet. So the purpose of a refrigerator cabinet is to insulate the refrigerator system in order to reduce the heat transfer from the surrounding to the inside of the cabinet. And if the refrigerator is not well insulated, more work needs to be done by the refrigerator in order to cool down the food. So for the material selection of a refrigerator cabinet, a low conduction coefficient material is selected, which is polypropylene, a commodity plastic with 0.1 to 0.22 thermal conductivity. So not only this engineering plastic is known to be a good insulator, it also have a high melting point at 160 degrees Celsius. So this is important in order to withstand the heat from the generator. And then to ensure that the refrigerator is well insulated, polyfoam will also be used in order to fill the gaps between the plastic sheets. So that's all for me. I'm going to pass the presentation to my other team member.
Good day, my name is Sivarajan. Today I'm going to present about the unit price of the refrigerator. So we have body, condenser, evaporator, square plate, thermostat, fuse plug, wire and connection box. And when we calculate the total cost, we are getting 203 ringgit and 90 cents. And we know that our profit should be 200%. So we multiply by 200 percentage, and our selling price is going to be 611 ringgit and 70 cents. Moving on to the IRR calculation. So we have the sale, fixed price, cost, variable cost, IFO, depreciation, EBIT, tax, ATOI, OCF, NWC, capital, development cost, and PCF. So we have to calculate all the values, and the last one PCF, we will be getting the final answer with the summations. So moving on to the payback period, we have to calculate the cumulative cash flow, where we have to minus the previous year by the current year, and we are getting a positive cash flow in year 1. So we know that the payback period is located in between year 0 and 1. So next I'm going to present about sustainability development goal. So sustainability goal 8 and 12 is linked to our product. Sustainability SDG 8 is the decent work and economic growth. So by doing this production company, we can provide a lot of workers and manpower. Goal 12 is responsible consumption and production in sustainable development. So we know that refrigerator has a lot of bad effects. So we will be responsible in producing the sustainable one. So let's look at the sustainability in market. So we are going to use polypropylene as the refrigerator cabinet. So as you all know, polypropylene is fully recyclable and does does not release any toxic chemical in the recycling process. So we can also recycle this refrigerator, and we also can give discount to customer who replace their old refrigerator with their new ones, and with the old ones we can uh, recycle it and do a new refrigerator. That's all from us. Thank you.